Today we're going to be talking about the mole, which is a quantity that we use in chemistry. We will be doing some calculations to make sure everybody understands what this concept means. First and foremost, a mole is a quantity. It is a quantity of items just like a dozen eggs, dozen donuts. Another quantity that we use in everyday life is a gross. So a gross is a dozen dozens. So a mole is just a quantity like these others, but a mole is a quantity that we use to describe a lab-sized sample. And so it is used almost exclusively in chemistry. And you can see here these 5 beakers and then this big ball of aluminum foil. These all represent a mole of each of these respective substances. The one on the left looks like sulfur. The fourth one from the left looks like copper. The one in the middle looks maybe like lead pellets. So each of these is, fits into a small beaker. So that's what we mean by a lab-sized sample. These are some more moles. So here we have some compounds and we have some elements. And then there are a few more moles here. So here we have a mole of helium, which represents a gas here, filling up this balloon. We have 2 solids in these watch glasses, sulfur and copper, and then we have a liquid, mercury. And these are also all elements. They are not compounds, but they are found on the periodic table, and I chose them on purpose. Here are a few more moles. These are the fuzzy animal variety. So this is the only animal slide we'll ever show in this class. You probably see a lot more in biology, but the mole is sort of chemistry's mascot, and that's the reason he is our mascot is because of this mole quantity that we use. So one thing I want to make sure is clear is that moles of different elements have different masses. And so we have the same picture on the right with helium and sulfur and copper and mercury. But each of these is a mole, but it has a different mass. And so a mole of helium has a mass of grams, a mole of sulfur has a mass of 32.06 grams, a mole of copper has a mass of 63.55 grams, a mole of mercury has a mass of 200.6 grams. It is not a coincidence that these numbers represent the masses that you see on the periodic table that I've circled in red at the bottom. I want to take a little side step. I know we talked about average masses or atomic masses in the last topic, but I want to make sure that this is clear. The average atomic mass values that you see on the table have multiple meanings. And so now we've seen the 2 meanings, and I want to just summarize those here. An atom of helium has an average mass of 4.00 AMU, or atomic mass units, but a mole of helium atoms has a mass of 4.00 grams. The same can be said for sulfur. An atom of sulfur has an average mass of 32.06 AMU, but a mole of sulfur has a mass of 32.06 grams. And that's true. You can make the same comparison for copper and mercury. So the average mass of the atoms is in atomic mass units that go along with the number on the table. But if you have a mole of that element, then that number represents the number of grams for 1 mole. Now the same picture, but now I want to talk about atoms. And so moles of different elements have different masses, but they have the same number of atoms. And so a mole of helium has 6.022 times 10 to the 23rd atoms, as does a mole of copper, as does a mole of mercury. So this is what is true about this quantity. It's just like a dozen is 12 and a gross is 144. A mole is 6.022 times 10 to the 23rd. So it is just a quantity, a number. It's a really large number, which is called Avogadro's number. Avogadro's number is abbreviated capital N with a subscript A, and it represents that number, 6.022 times 10 to the 23rd. It is the number of items, whatever item it is, in 1 mole of anything. So you can have a mole of Frisbees, you can have a mole of telephones, you can have a mole of French toast. That would be pretty weird. Normally, a mole represents a quantity of atoms or ions or molecules. We typically reserve it for lab-sized samples. It's a really, really large number, and there's an image in your book, which is shown here, which compares the mole, right, Avogadro's number, to different values, like the age of the universe in seconds, right? And you can see that a mole, Avogadro's number, is actually 6 orders of magnitude larger than the age of the universe, which is a pretty big number. Here's Avogadro with our joke of the day. Don't worry, you won't need to do a mole of practice problems to understand what a mole is. So, he's pretty funny. How many iron atoms are present in 0.15 mole of iron? So here we're just going to convert moles into iron atoms using Avogadro's number. So we take the number we're given, 0.15, and we're going to multiply that by Avogadro's number so that the moles cancels with moles in the denominator. And that's going to give us 9.033 times 10 to the 22nd. It's a big number. 0.15 has 2 sig figs, 6.022 has 4 sig figs, so our answer needs to be rounded to 2 significant figures. Don't forget the units or atoms. Part B, we're going to do a 2-step conversion from grams to moles and then from moles to atoms. To convert from grams to moles, we need to use the atomic mass of iron, so we're going to get out the periodic table, which is here. And iron is element 26, which has an average mass of 55.85. That means there's 55.85 grams in every mole of iron. So we're going to use that number as a conversion factor here to convert from grams to moles, which means we have 0.226 approximately moles of iron. And then we're going to use Avogadro's number to convert that into atoms. Moles cancels, and then we end up with a really big number, which you should anticipate, because 12 grams of iron, that's going to contain a lot of atoms of iron, right? Because atoms are tiny. So now we need to figure out the significant figures. 12.65 has 4 sig figs. 55.85 has 4 sig figs. And the Avogadro's number that we're given, 6.022, has 4 sig figs. So our answer needs to be rounded to 4 sig figs, which is here, 1.364 times 10 to the 23rd. Don't forget atoms is our unit.